Hello, students. Welcome to this session. This session is basically, based on electrical network subject, and I'm here to actually solve certain problems. Okay, so this is basically a live quiz. So let me actually tell you how this live quiz works. Okay, so first of all, if you want to join this quiz, you have to go to this website, or I would suggest, link that is bit.ly/TGA063E. So what you need to do is you have to type this link in a browser, okay, so that you can play this quiz. So you have to open two tabs. In one tab through which we are communicating with YouTube guys, and the other one tab where you will be playing the quiz. Okay, so now I will be giving you instructions how to play this quiz. Okay, so there we go. So as I said that you have to take this link, that is bit.ly/TGA063E. Type this link in your browser, open it, so that the quiz will come. Okay, the quiz means the question starts coming. Okay, and every question will have certain marks, but then the good thing is it do not have any negative marking. Okay, so you have to play it with brave heart, I would say. You need not to worry that what will happen if the question goes wrong, right, or the answer goes wrong. So there are absolutely no negative points. You need not to worry. Okay, so number of points and the questions will be displayed along with the question. Okay, so you need not to even ask that a particular question carrying how many marks. Tougher is the question, more is the point. Okay, and the real catch is that if you let's say 5 to 10 people are attending this quiz. Okay, and if somebody answers at a very first stage, he will get the maximum marks. Okay, so the faster you answer, higher you score. So this is all about this quiz, guys. Please go to bit.ly/TGA063E and please keep this window open, obviously. Okay, because else we cannot able to communicate. Of course, you have opened this. I'm sure you will enjoy this quiz. In the chat box, you can ask me the doubts. So this is not only about the quiz. At the end of this quiz, what I'm going to do, I'm going to solve these questions in detail. So stay tuned, guys. Let me see who all are joining. So I'm waiting for players to join. Let me see. If you have joined this quiz, tell even your friends. You can just send this quiz. So let me see now. Okay, so we have got multiple players here. Okay, now I can start my quiz. Oh, okay, we have got two players here, Radhi and Siva. Let me see. Let me start the quiz. So there are total 4 questions, guys. The first question is on your screen. The current flowing past a point in a device is as shown in the figure. As you can see, the graphical representation of the current is given, and what you have been asked is to calculate the total charge through the point. Okay, so current is given and the charge has been asked, okay, in microcoulombs. I'm sure you know the relation between current and the charge. Okay, I guess this much hint is enough for you. There are only 27 seconds are left now. Let me see how many people can answer this question. Okay, so we got 20 seconds now. Guys, this is very, very easy question. Very, very easy question. The graphical representation of the current is given and you have been asked the total charge passed through that point. Let me see how many people can answer. Okay, so countdown has started. It's 4, 3, 2, 1, and there we go. Let me see how many people have answered. Okay, that's great. So one student has given the correct answer. Let me see. We have a leaderboard here. Congratulations, Siva. Point. Okay. Other don't worry, even though you have lost this question. Absolutely nothing to worry. We have got 3 more questions to go. Okay. So here is question number 2 on your screen. Let me see. Okay. It's a very, very simple question, guys. Very, very simple question, guys. Okay. Please correct option B as 0 watt. Okay. So look at the circuit. For a circuit given, okay, you have to calculate the power delivered by 2 volt. You have to calculate power delivered by 2 volt. Okay. So this is the circuit, 1 ampere current source is given. So you can somehow, apply certain KCL and something like that. And you try to just calculate the current supplied by 2 volt. And I'm sure that will give you the power supplied by the source. Okay. So yes, so when it comes to power calculations, you can calculate power which is dissipated with respect to, I would say, resistor or associated with inductors and capacitor. And again, this will have another aspect when you calculate power delivered, okay, by a particular source. So just to give you a hint, power delivered by source is always voltage sourced by that source multiplied by current source. Okay, so if you can do that, I'm sure you will come up with the answer. Let me see who are going to answer my question here. Okay, so everyone has answered and everybody has got 2 watt. Oh, that's superb. That's superb. Okay, so everybody is in the competition now. I'm happy about it. Radhi, Power Star we have, and we have got Siva. Okay, so without wasting any time, I'm going to question number 3, which is nothing but the second last question of this quiz. Here we have the third question on the screen. So if I naught is equal to 3 ampere, following statements are true. Let me tell you, this is MSQ type question. So guys, not only one, but more than one options can be correct. Maybe 2 options can be correct. Maybe 3 options are correct, or you never know that all the 4 options can be correct. Okay. What if I naught is equal to 3 ampere, which is the current which is given over here. And they have given you certain statements. They have given you certain statements like what is voltage across 4 ohms. Try to calculate voltage across 4 ohms with the given data. It's a very simple question. Just apply Ohm's law and get your answers, guys. Okay. Since it is MSQ, multiple options are correct. So it is going to take a time, and that's the only reason why the maximum time is given for this question. Okay, so check it out. What is voltage across 4? Check it out. What is power absorbed by 16 ohms? Check it out. The value of Ix. Okay, and this is 2 ohms of resistor. Okay, so these are the multiple options are given. Let me see who all are going to answer this question. Okay, so to play such quiz, we have come up with many quiz. Okay, and if you really interested to attend such quiz, do share with your friends. Okay, do subscribe to our channel, the Gate Academy. Okay, so we take these quizzes into languages, English as well as Hindi. Okay, so everybody has answered. Let me see. Okay, very good. Let me go to the leaderboard. Okay, so here we have this leaderboard, and the winner of this quiz is Radhi. Heartiest congratulations, Radhi. So what I'll do, as I have promised, I'm going to actually. Okay, so we have got one more question, guys. So we cannot actually announce the winner. I'm so sorry for that. This is a very, very simple, silly question. They are asking you the value of the resistance. Let me see. It is just you have to calculate the total resistance as seen from terminal A and B. You can actually solve it, literally orally. It is that simple question. Just apply your series and parallel, fundamentals of calculating equivalent resistance, and I'm sure that will give you the correct answer. Okay, let me see who can answer. Okay, so we have got only 40 seconds, but believe me, guys, it is not going to take more than 10 seconds, okay, to solve such problem. It's a very simple, silly problem, guys. Okay, still you got half of the minute with you. 30 seconds are remaining now. Okay, let me see. I'm sure most of the people have already come up with the answer. Okay, so the countdown had started. So nearly now 10 seconds are left with you. Let me see. So there we go. So time up, guys. Okay, let me see how many have answered. Okay, so again, as I said, Radhi is the winner for this. Radhi, heartiest congratulations once again. Okay, so what I'll do is, I'll just share my another screen where I will be going on my tab and I will be solving these problems. Okay, so give me a second for that. So I'm sure you can see my screen, guys. Okay. So let us start with the very first question. Let us start with the very first question, guys. So we have current flowing through the pass point in a device. So the graphical representation was given, and you have been asked to calculate, the total charge. Okay. So it was a very simple question that I was saying. Okay. Okay. So I'm sure you know. I'm very much sure you know what is the relation. What is the relation between what? Come on, between the current and the charge. Okay, let me see how many people can tell me. Is there anybody who can tell me what is the relation between the current and the charge? Ola can answer me. Come on. Okay, very simple, guys. Okay, so current I is basically, dq by dt. Then can I say that q is simply integration of I dt? Because what have we have been asked is, regarding the charges, right? So obviously we have to answer that. Okay, so if you actually understand what is meant by integration, guys, is there anybody who can tell me what is the meaning of integration? Very simple. Integration means area under the curve, isn't it? It is that simple, guys. Okay, integration stands for area under the curve. So if I want to integrate the current, and if the current is given me in the graphical representation, why should I even go for such mathematics? It is better that if I go for area calculation, I'll go for area calculation. So how do we go about it? Very simple, very simple. As you can see, if I want to get the graphical area of this, I can actually divide this figure into two parts. The first part is a triangle, a right angle triangle. The other part is basically a rectangle. Okay, so it is just addition of these two figures. Okay, very simple. So what is the area of the right angle triangle? It is very simple. It is half into base into height. Okay, so let me go for it. So if I go for it, half into base. Come on, what is base? This is the base. As you can see, the length of this is 1. It's not just 1, it is 1 millisecond. So it is 1 to 10 to the power minus 3, correct? Into height, guys. And what is the height? Height is always over here. You have to observe over here. The height is, it is 10, but it's not just 10, it is 10 milliampere. So it is 10 to the power minus 3. I'm sure you understood that. Okay, so it's just half into base into height, as I said that. Now 10 to the power minus 3 and 10 to the power minus 3 will make it 10 to the power minus 6, and 10 to the power minus 6 makes it micro. Okay, so again, these two ones are 2 and 2 5s are 10. So moral of the story, this is totally, I can say, 5 micro. This gives you 5 micro as area. Over here, when I actually calculate, it is just L into B. Okay, length into breadth. So what is the length? Okay, so for example, length is 10, but it's not just 10, it is 10 milliampere, I would say, multiplied by this breadth is again 1. That is 1 into 10 to the power minus 3. So this gives you what? Micro. So come on. Area of the right angle triangle is 5 micro. area of the rectangle is 10 micro. If you want to calculate the total area, then it is 5 plus 10, which makes it 15 microcoulombs. Okay, so 15 microcoulombs is the correct answer. I'm sure, guys, if you have any doubts in this, please go and feel free to ask me through chats. Okay, let me go to the second question here. Okay, so they are asking you what is the power delivered by the source. What is the power delivered by the source? Okay, so let me just see over here. Let me just see over here. Okay, so what is going to happen is this is going to source in 1 ampere current. Okay, so how much I get over here is 1 ampere current, isn't it? Because of this 2 volt, I can say that 2 volt has appeared over here. Now from this, just by using Ohm's law, I can say V by R formula and I can get a current. Okay, so how much is the current going through this? Again, it is 2 by 1. It means it is 2 ampere. Okay, so I don't know what is the current, flowing through this, or current which is sourced by this voltage source. I don't know that. Okay, so let me assume this is X. So what I'm going to do over here, I'm going to apply KCL. Okay, so what is meant by KCL here? Okay, summation of all the currents is equal to 0. So I can consider incoming currents to be negative. I can consider outgoing currents to be positive. Again, it's not that rule. It's not that rocket science. You can go for reverse way, that you can assume incoming currents to be positive and outgoing currents to be negative. Okay, but always take it vice versa. So for me, I'm taking incoming currents to be negative. So minus X minus 1 plus 2 has to be 0. Okay, so what I have done is I have applied KCL at this point, guys. I have applied KCL at this point. Okay, so what am I supposed to get is X is equal to 1 ampere. X is equal to 1 ampere. Okay, so in fact I have got this 1 ampere current here, isn't it? Now whenever you want to calculate power, okay, power given by the source, it is always the source voltage multiplied by the current sourced. Okay, so what is the source voltage? Source voltage is 2. What is the current sourced by that voltage? It is 1. So how much it becomes? It is 2. Okay, so this is a printing mistake. This was 2 watt, and I'm sure in the original slide it was 2 watt only. So we have already considered option B as the correct option. So I'm sure now you have understood this problem. This was very, very easy problem, guys. Very easy problem. Okay, let me go to the next question now. Okay, so this is the third question that I have started with. I naught is equal to 3 ampere, and they're asking you which of the following statements are correct. Okay? So statements are given in terms of voltage, in terms of power and everything. So why not to actually calculate each and every current and the voltage? Okay, it is very simple. Let's go through this. Okay, so as you can see, I naught value, they have already given I naught value. How much it is? It is here. So tell me, guys, if the current is known and if the resistance is known, it is very easy to calculate the voltage across it. Just apply Ohm's law, current into resistance. So what do I get is 48 volt here. Yes or no? Now we have also heard that voltage across parallel circuit is same, meaning that voltage across every branch is now known to me, that is 48. So everywhere I'll be getting 48. Now from this, what I will do is I will try to calculate the current through every branch. So if I want to get a current through this branch, it is just voltage divided by the resistance, correct? So how much do I get over here? It's 6 ampere. Here I get 12 ampere. Okay. Here it is 48 divided by 2. So it is 24 ampere. Likewise, Okay. So now let me go through the every statement and let us verify which statement is correct, which statement is wrong. So first says that voltage across 4 is 48 volt. Okay. So voltage across 4 is 48 volt. Check it out. Voltage across 4 is 48 volt. Yes, it's indeed correct option, right? So I would say yes, option A is correct. Okay, but since it is MSQ, we have to go through each and every option. Now second says power absorbed by 16 ohms is 144 watt. Okay, so power absorbed by any resistor is simply given as I square R. Correct? So when it comes to a 16 ohms, okay, 16 ohms, it is I square R. What is the current flowing through this 3? So it is 3 square multiplied by 60. And of course, this is going to give you 144 watt. So again, option number B seems to be the correct option. Next is Ix value is 45 ampere. Okay, let's go through this. Ix value is 45 ampere. Okay, so this is 45 ampere. This is what they are claiming. As you can see by KCL, it is easy to determine. I can say that this is the total current which is getting divided into these small components, right? Okay, so if I just go on adding, 6. Okay, the first branch current is 6, then it is 12. That is the second branch current plus 24 plus 3 ampere. And this gives you 48 ampere. You can verify with your calculators, guys. It means even option C is correct. And the last option says 50% of Ix current flows through 2 ohms resistor. Okay, so if Ix is 45 ampere, guys, if Ix is 45 ampere, let us see half of 45 ampere current is flowing through 2 ohms resistor. Is that really valid? Is that really valid? Okay, so it seems to be quite invalid, guys. It seems to be invalid because 50% of the current is not flowing through 2 ohms, right? It is not flowing through 2 ohms. This is what they are claiming, that 50% of the Ix current it is flowing through 2 ohms resistor. So 50% of Ix current means it has to be half of 45. Okay, half of 45. So so definitely this is not true. This is not true. So option C has to be, option D has to be invalid, guys. Option D has to be invalid. In fact, option A, B, C has to be the correct options. Okay. So in this case, option A, B, and C are the correct options. I'm sure you all are following me. If you have any queries, guys, if you have any queries, do ask me. Do ask me, guys, if you have any query. Okay, so this is not 48, guys. This is 45. Okay, this is 45. Okay, just add it and you will get 45. It's not 48, it is 45. I'm sure I have corrected. KS. I hope you all are there, guys. Okay, so let me just go to the last problem that we have over here. Okay, so here we have we have to calculate the equivalent resistance as seen between A and B. So RAB is something that we are supposed to calculate, and as I said that it was very simple, guys. Okay, so 5 and 5, as you can see, it is in series, right? So 5 and 5 gives you how much, guys? Come on, it gives you 10. As you can see, this 10 and 10 are in parallel. Okay, if they are in parallel, what is going to happen? Come on, 10 parallel to 10. So when two equal resistors are connected in parallel, effective is always half of it. Am I right? Okay, so 10 parallel to 10 gives me 5. So effectively, I can write, I can actually go like this. So this is 5 ohms. So up to this, I have evaluated that this is 5. So this is 5. Then over here we have 5. And at the end, what we have is 10. And then there are 2 points called as A and B. Correct? Again, 5 and 5 are in series, gives you 10. And then 10 parallel to 10, of course, it is 5. So at the end, what do you get is 5 ohms. So 5 ohms is the correct answer, guys. So I'm sure you have enjoyed this quiz. If you have any suggestions or anything you want to say, if you want to demand a particular subject quiz or a topic quiz, you can definitely demand in our text messages. So guys, I'm sure you must have enjoyed this quiz. To enjoy such quiz, do subscribe to our channel, do share with your friends, and do even share this lecture with your friends, so they will also come to know what kind of activities they are going in the GATE Academy. So thank you so much for having a lot of patience. I have enjoyed this quiz with you guys, and I'm sure you have enjoyed it a lot. Thank you so much.